there, y'all. Today we're going to look at 2.4 on solving literal equations. In this section, the objective is that you'll be able to solve an equation with variables for a specific variable. And these are also called literal equations. And the standard is that we solve literal equations and formulas for a specified variable, including equations and formulas that arise in a variety of disciplines. And so there's a couple of definitions that we need to talk about first. We need to talk about what is a formula. And a formula is a mathematical relationship or a rule that is expressed with symbols. And so some formulas that we think about, we talk about like y equals mx plus b as our slope-intercept form, right? Or we talk about that area is equal to length times width, the area of a rectangle. And so we have these formulas that are expressed with symbols before we put any values into them. Now, these variables that are in there, they are symbols that stand in the place of an unknown value. And so a couple things I want you to understand. The first is that a variable is just a number, right? A variable is just a number. Now, what do I mean by that? Well, it's a value that we don't know, but it's still a number. And so when we want to work with it, and this is number 2, that if you can do it to a number, you can do it to a variable. So if I were to replace, like in y equals mx plus b, and I've got a 3 for the m and a 5 for the b, and we wanted to subtract 5 from both sides, I would subtract 5, right, and move it across the equal sign. But if I wanted to solve y equals mx plus b with the b there, then I just subtract the b. Because if I can do it to a number, I can do it to a variable. And so we're going to look at a couple of examples of how we solve for specified variables. And so in example 1a, we're asked to solve d equals rt, and we want to solve it for t. And so when we look at this problem, we're going to highlight, circle, do something to the variable we want to get by itself. Because we're going to use our order of operations, our PEMDAS, right? And remember that if our direction is to solve, I'm working up the order of operations. And so I'm going to undo whatever is attached to that variable. And so in this case, I'm going to divide both sides because r is multiplied to t. So we're undoing multiplication by division. And so divide both sides by r. The r's over here cancel because r divided by r is 1. And so d over r is equal to t. And remember, we're asking to be solved for a certain variable. We're asking for that variable to be by itself for its final answer. And so t is by itself. Everything else is on the other side of the equal sign. So as we look at example b here, y equals mx plus b, we want to solve it for m. And so as we look at this example, here's the m right here. So what do we need to get rid of? And we need to do it in the proper order of operations. So the first thing I need to get rid of is any addition or subtraction that's attached to the m. And so the x is attached to the m by multiplication. The b is attached to all that by addition. And so we're going to first subtract b from both sides of the equation. When we subtract the b, we get y minus b, because those aren't like terms, so we can't like cancel them or combine them into one thing. So we just have to say what it says. It says y minus b. The other side is mx. And so then we need to get this m by itself. Always pay attention to what you're solving for. And so what's attached still? That's the x. So we're going to divide by x to both sides. And again, what you do to one side, you have to do to the other side. And so the x's here will cancel. There's nothing that will simplify with that left side. So we write just what it says. Y minus b all over x is equal to m. That's the final equation solved for m. And again, don't get overcomplicated. Don't try and be fancy with it. Just do what the next step is. Again, start with your addition subtraction, work your way up the order of operations. And again, if I have anything in parentheses, we're going to deal with that once we get rid of everything else first, and then we'll deal with stuff inside the parentheses. Okay? So let's look at example C. In example C, we see here that we have A, parentheses, x minus b is equal to c. Now we have this stipulation that we're told that a cannot be equal to 0. That's a little bit of a hint in this problem because there's only one operation that I would want to restrict a variable to not be 0, and that's division. So that means at some point I'm going to be dividing by a. Now in this problem, we're solving it for b. So I'm trying to get this b by itself in the end. So what's the first thing we need to solve for? So on that side of the equal sign, on the left side, we're trying to move the a first because it's outside the parentheses. And so remember that when a variable or a number is touching a parenthesis, we would normally distribute that in, right? So I would multiply this to a to x and a to that negative b. But I'm trying to undo everything. And so if the a is multiplying in through the distributive property, to undo this, I'm going to divide it, because again, the opposite of multiplication is division. And so I'm going to divide both sides by a. So the a's will cancel, and I'm left with the x minus b is equal to c over a. And so we get just an expression there, c over a. There's nothing we can do to simplify it any further. And so our next step is that we're going to get rid of these parentheses because there's nothing left outside the parentheses anymore. And so our next step is to get this b by itself. And so I'm going to subtract x from both sides. The x's will cancel. The negative's got to come down. And so we get c over a, and then just copy what's behind it, minus x. And so our final step is to get the b by itself. And so what's actually in front of this b? Remember, there's a 1 here, right? And so we're going to divide both sides by negative 1. Now, that cancels the negative on the left. And on the right, remember that dividing by a negative is just going to change the signs of what we have. And so the c over a is going to become negative. And negative divided by a negative is a positive for the x. And so we can rearrange this so that the positive's first. So x minus c over a. Either one of these two answers are acceptable final answers to this problem. So that's where we're at with simplifying and solving these for a specified variable. So let's take a look at example 2 here. In Bismarck, North Dakota, it can get very cold. The record low temperature is negative 45 degrees Fahrenheit. Our friends in Canada use the Celsius scale to measure temperature. The formula F equals 9/5 C plus 32 is used to convert between the two temperature scales. Solve the formula for C and then find the temperature in Celsius. So we're first asked here to solve this formula. So F is equal to 9/5 C plus 32. And so we want to solve this for C. And so doing that, we're trying to get everything away from the C. And remember, we're using PEMDAS, right? So we're going to undo our operations in the proper order. And so the 9/5 is multiplied to the C. But the 32 is added to the C. So that's what we're going to get rid of first. So minus 32 minus 32. Those will cancel. We get F minus 32 is equal to 9/5 C. Now, when we look at the next step here, we see that we have 9/5 C. So remember, that's multiplication. And so to undo multiplication, we have to do what? Divide. But when we divide fractions, we really have to multiply by what? The reciprocal. So remember, multiply by the reciprocal, right? And so that's what we're doing when we divide, right? So if I'm going to multiply by the reciprocal, that means I'm going to multiply by what? 5/9. And so we multiply this side by 5/9. And we multiply this side by 5/9. And again, what we're doing to one side, we're doing to the other side. Now with multiplication, that means potentially we have to distribute sometimes. In this case, we're not, but we could if it's going to simplify the problem further. And so the 9/5 and the 5/9 will cancel. And so we get 5/9 F minus 32 is all equal to C. So this is it solved for C. Now, the reason we solved this for C is that now we can plug in any temperature in Fahrenheit and just do our order of operations down to simplify it. And so in this case, we're going to plug in that negative 45. And so doing that, we get that 5/9. The f is negative 45 minus 32 is equal to c. And so negative 45 minus 32 is negative 77. And multiplying this out, we get 5 times the negative 77, so it's negative 385 being divided by the 9. And 385 divided by 9 is negative 42.7 repeating. And so negative 45 degrees Fahrenheit is negative 42.7 repeating degrees Celsius. And so that's what we're looking at. If we wanted to do this for 105 degrees, right? Let's say the highest temperature in Bismarck, North Dakota was 105. We could do this again, same formula, right? Except now plugging in 105. And again, be able to simplify it down and get to what C would be equal to. That's the purpose of being able to solve these formulas, is that we're able to use them to simplify things later down the road. So that's it for section 2.4. If you have any questions, make sure you ask. But that is it. So y'all have a good one. To catch you next time.